seasonal mobile developer. So I started with the Android, then I found Flutter, then I got into Flutter. My backend language is Spring, just by the way. So I'd like to get to know you guys a bit more better, so I know how to deliver the content. So maybe just maybe tell me your name and maybe how long you've used Flutter for. Maybe you can start with me. How long have you?
6 years.
6 years.
Very fast, 3 years.
Pleasure.
6 plus.
6+ years. What's your name?
Maureen.
Maureen. How about you?
Peter,
Peter, how long?
3 years.
3 years.
Axel. Axel, I think 3 years, 6. I can't remember. I've been doing mobile for.
No, it's 1 month. 5 years. Okay, good. So I think we are good here. So my talk today is about MVVM, specifically mobile development architecture. So architecture is something very important, especially when you're doing mobile apps. I'm sure we've all been in that situation where you've been given a code base, you don't even know where to start. So to avoid being in that situation, architecture is what comes into place. So you have well-defined functions, well-defined APIs that make it easy for you to use. When you get packages, and they're so easy for you to use that you don't even need to go to the documentation. So that's what I'm hoping you learn from this talk. Okay. So what to expect from this talk? I'll teach you about architecture principles. You need to know how to build good architectures from the base ground going up. I'll teach you about layered architecture, how to structure your application into layers. There are 3 layers, and we'll talk about them later. I'll teach you about MVVM. MVVM is a view model architecture. It's a design pattern that you use for mostly mobile apps. I'll teach you about dependency injection, dependency inversion, modularization, and I'll give you some recommendations on how to improve your application. So this is the application I developed to illustrate MVVM architecture. It's a GitHub link to the APK, so if you want, if you have an Android, you can scan and you can download and check it out. You can tell me when you're done. Okay. You good? So I'll be shifting a bit of topics, a bit of code, so that you practically see what's happening. Okay. So the principles, architecture principles. So the first major, most important principle is separation of concern. So this is dividing an application's functionality into distinct independent units. So when you're developing an application, it's easier to focus on one thing. When you have a function should not do too many things. It should do one specific thing. If it's validation, email validation, it's just that, nothing else. It makes it easy for you to write your code and to find bugs when you're debugging. This also involves classes. Classes should also have one functionality. So your class should not do anything. It should not have many reasons to change. So that's separation of concern. So layered architecture, it's to organize an application into distinct layers with specific roles and responsibilities. So we'll get into that more later in the topic. There's also a single source of truth. So this source of truth is responsible for representing local or remote state. If the data can be modified in the app, the single source of truth class should be the only class that can do so. So this one is about owning the data. When you have, let's say, a repository, like a user repository, only that user repository should be responsible for changing the data. nothing else should change the data. You should not have side effects where you have maybe a message, your message repository changing something in your user repository. You should have a way to communicate. The repository should own that data. Next, you have unidirectional data flow. So state flows from the data layer. So okay, there are 3 layers. I didn't talk about them, but we have 3 layers. We have the data layer, and we have the UI layer, and in the middle we have a logic layer. So state should always flow from the data layer through the logic layer and eventually the widgets UI layer. UI interaction should flow the opposite direction, from the representation layer back to the logic layer and to the data layer. So this is when, let's say, if you're a fan of block fans, so what it enforces is you have an action that's probably like from a button or something. So you press the button, it prompts an action in the block, and then does some processing, changes something from the data, and then you find the result bubbles up back to the logic and back to the UI. So that's unidirectional data flow. So extensibility. Each piece of architecture should have a well-defined list of inputs and outputs. So this is when you're developing like an API or maybe an SDK for someone to use. You have, you don't have maybe too many functions that maybe do the same thing. Have one function, the rest should be private and should be hidden. So this makes it easier for you to let's say to expose the API for many people to use. Testability, right? You should be able to write independent isolated tests for each unit. So each unit should be should have one single function that you can test. If it's, for example, you're testing UI, you're just testing if it's present, a component is present or not. If it's let's say a repository, you're just testing if it can store data or not. Yeah. So let's dive into layer architecture.
I have a question.
Yes.
On the matters of the UI and the data and the logic layer, should the UI layer know that the data layer exists, or are they separately segmented?
It's a good question. I'll get into that later in the topic. Oh, by the way, I forgot to mention. So if you have a question, you can submit them on this QR code you can scan. You can write all of them in case I miss something, and then at the end of the topic, I'll get into them. Yeah. You good? Okay. So layer architecture. So this one, I took some principles from Android itself and from Flutter, just to compare. So first batch will probably be from Android. So there are 3 layers: is data layer, the domain layer, and the UI layer. So this is how they flow, and that's how this is the hierarchy. So the domain layer is optional. You may, if you have a simple app, you probably won't need it. So let's start with the data layer. So the data layer of an app contains the business logic. This is what gives your app value. It's made of rules that determine how your app creates, stores, and changes data. For example, if you have a database and you want to enforce some rules like a unique username, this is where we put that kind of business logic. That's what we're talking about. So our data layer consists of 2 components: repositories and your data sources. So repositories they are responsible for, they own a type of data. If you have, for example, user type data, you have a user repository. It will be a single source of truth, responsible for any user operation. So this makes it easy for you to, when you're finding maybe a bug on the user, that's where you will check, because it does everything else related to user. No other repository should do that. And your data sources are what actually provide the repositories with data. This could be like a local database, it could be a remote server. Yeah. So these are the responsibilities of the layers. So for the data layer, it's responsible for retrieving raw data from external sources. The data layer should be free of any specific domain or business logic. Ideally, packages within the data layer could be plugged into unrelated projects that need to retrieve data from the same source. So let's say you're building an application that involves a common base. Let's say you're building a point of sale system. So you have different types of roles for the users. You want to build different applications. You want to build an application for the shop owner. You want to build an application for the admin. You'll find that some calls are the same, like getting a user logging in. Those are very common things. So that's what you put in your data layer. You can package it into a module, and when you have the different applications, you just import the same module. So you gain that advantage when you clearly separate all the functions from it. Your domain layer. So this layer comprises of one or more repositories and contains logic for how to surface the business rules via specific feature or use case by fetching data from one or more data sources from the data layer. So domain layer, as I said, it's optional. You won't always have it, but when you have it, it makes it easy for you to connect the two layers. It does heavy computation or complex use cases, getting data from the data layer and presenting it to the presentation layer. You may find that the models in the domain layer are different from the data layer, but maybe common in the presentation layer. So the presentation layer is the layer that, for this one, it includes Flutter UI dependencies. It's responsible for building widgets and managing the widgets lifecycle. So the presentation layer here, we can talk about the UI. Whatever paints the UI, whatever you see as a user, is all in the presentation layer. So before you get to the presentation layer, there is nothing like UI. There is no, depending on how you want to structure application, but when I do it, there is no UI of the domain in the data layer. The data layer is purely that. The domain layer, it's a package in Flutter, and the presentation layer is now the application itself. Right. So repositories. But if you have a burning question and you feel like I shouldn't continue without asking, you can tell me. Right. So repositories. You should create a repository class for each different data type you handle in your app. The use of the repository layers exposing data to the rest of the application, centralizing changes into the data, resolving conflicts between multiple data sources. Like if you have a cache, you have a remote server or a local DB, the repository should be responsible for providing the single source of truth. It's what actually tells your app this is the state you should be in. It's responsible for extracting sources of data from the rest of the application, and it contains business logic. So let me talk, this is the most important layer. You'll find yourself spending most of your time in this layer, in this component. So for repositories, let's say you have a user repository. It should be responsible for updating the data on the remote server. It should be responsible for caching the user into a local database. Responsible for any updates, any CRUD operations that you do. All should be in the user repository and not in another class. So when you're creating a user repository, it should just expose methods to update the user, and this should be done all in the repository. So the domain layer. Okay, I think I said I'd mix some code and some, so we don't, so you know what we're talking about. So this is the app you downloaded. If you manage to download, this is basically the application. So let me give you a small tour. So these are all the packages. I decided to put them all in this folder so it's easy to see. But most of these packages, they live in Git, and I just import them. So we have the three layers are here. So this device chat is the presentation. This is the data layer, and that's the domain layer. So in the data layer is where you have your repositories. Yeah. So I have 3 repositories. The device repository is what will be your user repository. So the app is called device chat. It's for devices to chat. Any device you have, you can install the application, you get a unique device ID, and you can just start chatting the device. So this is this is a repository, for example. So this way we have defined inputs and outputs. So this repository has functions to modify that. The data type is called device local. So all this repository does is mutate that data and provide ways to access the data. Has well-defined inputs and outputs, and as a senior dev, what you can be doing, maybe because this is about collaboration, what you can be doing is you can split your work between the 3 layers, and you have you can define, this is like the API. You define how this repository is going to be used. There's no implementation here, as you see, it's just functions. You define, you can give some comments, say this is what you expect from the function. This is what you provide. These are the errors, possible errors that you'll get. So once you do this, it's easy. You're left to someone else to implement it. You don't need to worry about how it's going to be implemented. This is just what you expect from the API, and this is what you get, and this is what you work with. This makes it easy to test, as it's abstract, and you can provide any implementation. You can provide a mock implementation. So that's how a repository would look like. As I said, the data layer doesn't provide any implementations. It's just abstract. Okay. So the domain layer. We are good now. Any questions? Okay. So an optional layer that sits between the UI and the data encapsulates complex business logic used by multiple models into use cases. So why we have a domain layer? It avoids code duplication. It improves the ability in classes that use domain layer classes. It improves the stability of the app. It avoids large classes by allowing it to split responsibilities. So we have these things called use cases. So let's check into the domain layer. So we have these use cases. Something like login use case. It implements 2 repositories, a local device repository and a remote device repository. What it does is it checks if you're registered online using the remote device repository, and if you are, it will just log you in. It will get your data, save it in the local repository, and log you in. These repositories are still the abstract classes that you saw, so there is no implementation provided as of now. Everything is just abstract. So you have you know what you're going to do. You have well-structured inputs and outputs, and so you can just define. This is how you can define workflows. You're going to fetch from the repository, get data if you can manage errors also from here. But at this point, you don't know how the internal workings of the functions. You don't know what they do. You just know what you expect and how to handle them. This makes it easy for you to write your APIs. So this is a use case. The reason it's complex is it takes data from 1 or 2 more repositories. So having it here, you just provide this API is like sign-in device. This is all you provide to the UI, and it's easy for the UI person to build the UI and not worry about what is actually happening behind the logic. Yeah. So that's an example. I also have this other use case called get media use case. It fetches media from the remote repository, but first checks if it's in the local repository. If it's not in the local repository, it checks in the remote repository. I'll give you a good tour of the code once I'm done with the presentation. Okay. So use cases should be named after single actions they're responsible for. Like for example, get media use case. It's an action. So it just makes complex UI, complex logic simple into a single function or an action. So you should create new instances of a use case every time you pass it as a dependency. So a use case shouldn't contain any state. It should just be text repositories and it's just functions. So the reason it doesn't contain any state is you shouldn't have any side effects. Side effects, they come in when you like one part of the application says this, but another one says this. So use cases are just functions. They just help you in doing complex actions. Yes. So you shouldn't contain any mutable data. Yeah. So, however, the potentially significant disadvantage is it forces you to add use cases even when they are just simple functions. Like for example, I think I have this somewhere. Let's see. I guess I don't have it here. It's another application. But the domain layer is optional. You don't really need it. It's only when you have complexity that you want to use it. Okay, so now let's get to the UI layer. The role of the UI layer or presentation layer is to display the application data on the screen. So the UI layer is composed of UI elements. That is your forms, your buttons, everything on the UI, and your stakeholders. So here is where you have your state, state management tools. So here you're free to choose whatever you want at this point. So it should be pretty easy when you have layered architecture. Just swap out block, use change notifier, use signals, whatever you want, because it's all here on the stakeholders. So this is how data should flow from the data layer to the UI layer. So the data that's producing layer, that's your data layer. It goes through the business logic. That could be your domain layer. Then your screen UI state, that could be your models or your block. Then now it goes to the UI logic. UI logic is where you have things like, should show this check button or not. Just simple logic. The element state, now that's is showing the check button or not, and then now the views themselves. Okay. So now now we're getting to MVVM. Any questions so far? Okay. So far? So now this one is more about Flutter. So if you guys have Menga code documentation, maybe the architecture documentation, you'll see some. That's where I got most of my information. It didn't come from the place the sun don't shine. It actually has some truth to it. So in MVVM, views and view models make up the UI layer of the application, as you can see here. So here there's no domain layer. It's just split into the UI and the data layer, because this is what is actually the core. The domain is optional. So every instance of a paired view and view model defines one feature in your app. So a view is not necessarily a screen. A view can be a button, and it can have its own view model. So the purpose of a view is to display the actual state. So UI is a function of state. It's a function that represents a specific state at a specific time. So a view model is responsible for holding that state for the UI. So every view has one single view model. You should not share view models. You have one single view model for one view. So repositories and services represent the data part of the application. So repositories also, they have the single source of truth where they hold the state for that specific data type. And services could be like your DO, your network service that gets that interacts outside of the application. Things like OS services. So anything that interacts outside the application should be in the service layer. Your repository is a single source of truth. And how repositories and view models, the relationship is, your view model could have many repositories. Your repository can have many services, and it all flows in one direction. Okay. So why MVVM? So main thing is maintainability. So it makes it easy to make updates, modify and fix issues over time. If you ever struggled with, I have Whoever struggles like with making feature updates, you're told to put this update, told to add this feature, and you're not sure where you're going to add it. It can be tough because now you're going to have, I don't know, should I put it in this function? Should I make a new class for it? So it makes it easy to add that change, and I'll show you how. Scalability. A well-thought application allows more people to contribute to the same code base concurrently with minimal conflicts. So if you have, if you're working with multiple people, and you might find that you're touching the same classes, you have Git, merge conflicts, you have all these crazy things when you decide to merge your code. So MVVM helps with that by splitting all the features into specific units. So when you're working on a feature, you're just working on that, and you're not going to break the entire application. So if you're maybe freelancing and you feel like you want to hire a developer, an external developer to do some work, and you're worried that they may break your application, MVVM will help you not worry about that, because you'll give them a specific feature to work with, and not worry about breaking the rest of the application. So it also lowers cognitive load. So developers who are new to the project will be more productive in a short amount of time. Code reviews are generally less time consuming when code is easier to understand. So when you get into a project, have you ever been given a code base and you just work with what is that? Because it's all over the place. GUI data is there, the navigation is there. At the same time, navigation is here. It can be hard. So you spend so much time learning the code base instead of actually doing the change you're supposed to do. And MVVM is here for you. Testability. Applications with internal architecture generally have simpler classes with well-defined inputs and outputs, which makes them easier to mock and test. Like for example, the repository I'm showing you, it's abstract. So you can provide multiple implementations of this. You can provide a mock implementation. You can decide to use like a hash map for the actual database. It's easy to mock and test. Okay. So MVVM, it has view models, and models. So let's get into the rules of how each of these components play a part. So for views, this one is more straightforward. So it describes how to present an application data to the user. When you write a stateless widget, you have some inputs. You're defining how this widget should look at a certain point in time. A checkbox, when it's checked, should look like this. A form when it has an error should look like this. It's easy to do. I think it's really easy to just do the UI when it's just static, you know. So those are what views are for. You just make your UIs. At this point, they should look like this. At this other point, they should look like this. It really makes it easy and fun to do UI. So each view depends on one view model for the data. Views pass data from user to the view model. So when you have a button and you press login, like the way we saw in the previous application, you pass those fields, the username, the email, the password to the view model. So the data flows from the view to the view model, and then now the logic is done on the view model side. So views should only have UI logic. UI logic is simple statements and flags that show how the state is. Animation logic, simple routing. All routing should be done on the views, please. Thank you. Layout logic based on device information. Pardon? GetX, yeah. The things is so. Yeah, so everything should be clear. When somebody is looking for what's happening, they can clearly see everything on the view. So, view models now. So they contain the logic that converts up to into UI states. So state UI is just a function of state. It's a function that draws the current state. View model logic, retrieving application data from repositories. Those are the functions. Transforming data into a format suitable for presentation in a view. If you need to do filtering on some data, you need to do sorting on some data, this is where you do it in the view model. Maintaining the current state needed in view. then exposes callbacks to that view that can be attached to event handlers. So things like the sign-in button, when you pass in those fields, so those are the callbacks that you expose. So the view model will outlive, okay, let's say if you destroy the view and you need to quickly rebuild it, the view model will hold that data. So you'll notice that the data is still the same way you left it, but the view is always being rebuilt and rebuilt. So you'll actually notice like a significant UI improvement. I did. Okay, so models now. So models is just the, this is really used to confuse me when learning about MVVM or when people used to talk about MVVM. I thought model was just the classes that hold your data. So model is actually the logic part of your business. So your entities, especially your entities, because that's what you work with now. That's what has the actual data for your application. So it handles business logic made up of services and repositories. So repositories, as I say, it's a single source of truth. So each data type has its own repository. You have your user, you have your device, you have your message. So those are each entity which you have its own source of truth, its own repository. It's responsible for caching that data, error handling, retry logic, refreshing data, polling services for new data, refreshing data based on user actions. Okay. Services, they are stateless. They're only used to isolate data, loading the whole no state. Things like getting data from your Android device, it's just a function, holds no state. Calling an external API, it doesn't hold any state. It can be called as many times as possible. So your app should have one service class per data source. Meaning, let's say you have a user repository, then you have APIs for that user. So all APIs for that user should be stored in that service class, and you import it in your repository. So services and repositories have a many-to-many relationship, meaning many repositories can use many services. So these are the rules of engagement between the components. So let's start from the service. So from the service, they are not, this is your question now, the question you're asking. So services are not aware of repositories. When you build a service, you just build that service. You shouldn't know where you're going to use it. It just has that same functionality. So I'll show you an example. So I have, let's get the data there. So I have services here. So I have a networking service. So I have this function that sends data to the backend API, that sends files to the backend API and downloads the same files. So it's just a function. You can use it anywhere. It's not aware of any repository, but it just has whatever it needs to get to do its functions. So this service is what you import on the repository. So it's not aware of any repository, but you can use it in multiple repositories. So repositories, they are aware of many services, meaning you can import multiple services into a repository as long as you need that functionality the service provides. So they can be, pass services into the repository as arguments can be used by many view models, but they're not aware of them. So repositories are not aware of view models. They just act as themselves. Anything to create a user, you provide arguments to create a user, and it creates a user. And it's not aware of where it's going to be used. It's just that's its function. View models. Okay, so let me show you a repository, an implementation. So I have local and device. So this application, it's offline, but all data that's coming online will be stored on the local device. So for example, let me show an implementation of this local device repository. So the local uses a local storage service. So you inject the service into the repository and you use it. So it has functions like, this is the service itself, like saving a device, getting a device, see, clearing all devices, saving messages, getting messages. Those are the functions of the local data storage. So you inject that local data storage into the repository, and it does these functions of getting the device, things like saving the device, clearing all the devices. Everything here is relating to that device. Yeah. So, and there's no view model here. It just does what it's supposed to do. So the view model, it belongs to exactly one view, and it's not aware of that view. So, meaning it shouldn't react based on that view. It should just do what it's supposed to do, and it's now injected to the view. So the view is what's aware of it, and the view should react to it. So you can inject multiple repositories into your view model as long as you need that functionality. Let me show you a view model. So now we're going to the presentation layer. So let me show you the login view model. So you have, this is your login screen. The login screen is where you inject the view model as a constructor. And let me show you the view model. So for this project, I decided to use change notifiers. I decided to use most things that are from Flutter itself, without external dependencies, many of them. So for this, you inject, I have a login use case, which I injected. So my use case is the one that has the repositories. But in another scenario, if I didn't need this complexity, I could just take these two repositories and use them in the login view model. I can just inject them here and just use those functions. So for the change notifier, if you've never used it, all you need to do is call notify listeners to actually update the UI. So anytime you see notify listeners is when the UI actually updates. So you can do all your logic in here, and then you only update the UI when you need to. All right. So that's on the login view model. So it's injected to the login screen, and you listen to that view by using a listenable builder. The listenable is the view model, and here is what rebuilds. Whatever is inside is what rebuilds. So that's when views. Alright. So this is how the interaction is between the layers. So you have your external data. Let's start from the right. So these are maybe your services. So your service it wraps an API call. I don't know if I can. Yeah. So I can show you what's happening. So the service wraps an API call. So if I go to my service, I have this network, this API. So what this does is just has API calls here. It sends a request to this path, uploads the service and returns. That's all the service does. So that's what you see here. Then the repository is what we'll use. We'll inject this service. So if you see in the domain layer where I've implemented that repository, you'll see that I've injected. Okay, so there's remote storage service. So I've injected that service into here. So you inject the service, and that's what the repository uses. So that's what does the actual downloading and error handling. So here you'll see some error handling on app failure, on socket exception, on the exception. So here's where I do all the error handling. So here's where most of the work will be, and then all you just return is the results. A result, if you know sales classes, you can just use the results. Then a result can be either this class or this class. It can be an error or a success. But every time you're returning a result. So I prefer freezed. I just kept this here so you can see. So for freezed, you can either have a success result or an error result. So this makes it easier to display an error to your user. From wherever it happened, it can happen, the error can happen on the repository, on the domain, but it's easy to show that error. It can bubble up all the way. So that's on services, on repositories. And now on the view models, it injects those repositories in the view model and handles now view logic. For example, if you need, like after passing the data, it's the one that initiates all the calls to the repository to like create a user, create a device. Yeah, and then the UI is pretty simple. It just displays the data and listens for events. That's all the UI should be worried about. So the domain layer. So use cases are responsible for making interactions between the UI and the data layers simple and more usable. They take data from repositories and make it suitable for the UI. Use cases are primarily to encapsulate business logic that would otherwise live in view models. The logic will be reused for different view models, requires merging data from multiple repositories, and is exceedingly complex. That's when you would use a domain layer. So in my example, I have the login view model. Let me show you the login use case. Let me show you a complex one. Actually, when you get a message, when you send a message, this one is a complex one. So yeah, as you can see, it injects 4 repositories into it: the local device, local message, remote message, and remote media. So when you're sending a message, you either sending a text, you're sending an image, then you need to know the device you're sending to. So it needs to aggregate all this logic to find out who you're sending to. So the first thing is I need to get the current user device. So you get the current user device from the local repository. Once you do that, you create a message to the remote device. And then once you do that, you save that message to the local repository. And then now you can bring that message back to the user. So that's like a complex operation. Can you imagine doing all that in a view model? It will be really hectic, especially if maybe your strength is not in logic and it's in UI. So having this separation will easily make it work for multiple developers. Like let's say, for example, I'm not good in logic in creating UIs. I can attest to that. But like I'm good in like writing logic. So I can easily write this logic. I can write this logic easily and just surface back these results to the user. So, for example, if I'm a senior dev and I'm thinking about how to scale this, how to write this application in time, and I have a team, so I just need to know, okay, you are good in writing logic, you write this use case, this domain layer, I'll do the data layer, I'll define how the application is structured, and since you're strengthened in doing UI, you just focus on the UI. At this point, just draw how it will look, and at some point it will be easy to merge in no time, in no stress. You don't have to be worried too much about, oh, I'm not good in data, I'm not good in writing logic. It's easy, it can be easy for you. Okay. That's on the domain layer. So Flutter provides a way to package your structure. So there's by feature and by type. So by feature and by type. So these are the different layers. So you can see here the data layer, here the domain layer, and here the UI layer. So on the data layer you have your repositories, services, and models. That's by type. It's been grouped by type. So you put all the repositories together, all your services together, and all your models together. For the domain layer, you have your models there. You can have your use cases. What I've done different from them is I've implemented all my repositories on the domain layer, because that's like the complex layer. you might notice some people recommend you do it in the data layer, but if you're using something like Firebase, you know Firebase depends on Flutter. So, and my data layer is just purely that. If you look at it, if you look at the pub spec, it's just purely a Dart project. It has few dependencies and just like the exceptions, network service, and some common functions. It doesn't do much, it's just definitions. So when you go to the domain layer, you might find that's when I actually depend on Flutter. So that's why I have Firebase, my Dio, Hive, secure storage. So that's where I can actually build most of the things. So from my experience, I find it's actually better to do most of the heavy work on the domain layer. Yeah. So so for my domain layer, you'll find that I have the implementation of the services and the repositories. Yeah, so they're all here, all the implementations are there. So it's also easy to provide multiple implementations. Like for example, for the media, I had remote file storage, yeah. So I was using Firebase originally. If you use file cloud storage, this is how it looks. You use Firebase storage, the instance, and then you get a ref. So I've written all the code, I'm relaxed. Now I'm trying to use it and I can't. Kumbe now they started charging people to use. Hey, so I was like, okay, now what do I do? So I decided, okay, let me create my own backend. And so originally I defined this service, remote file storage service. All this does is upload and download a file, a binary. So so that's what I implemented here. So I decided, okay, let me just swap out the Firebase with my backend. So I just implemented the same repository, the same service, and just provided, injected the service here. So now everything is just working on the API using the backend that I made. So it was seamless. It was really easy to change. If you see on my main method, how I swapped it, it was like this. This was the original remote file storage service is equals to Firebase cloud storage. So it was really easy to swap. I just swapped out the implementation. So that's what MVVM helps you with. If you don't like a feature, it's not really serving you. You just swap out the implementation like that. You can hire a dev, maybe somebody who's good in something. In that feature, you can just swap it out like that, and your app still remains the same. I didn't really have to change a lot of code. So those are the advantages MVVM helps you with. For the UI, you have your core here, where you have like your shared widgets and your themes, and then and the features. You have each feature with the view model and the widgets. So for me on the UI, I have my presentation here. I have my routing there. For my routing, I just use the roots. I just use this function for the roots, get roots, which provides your context, and that's where I build all my view models. So each view should have its own view model. So when you're creating that view is when I create the view model. Axel, he had that question, Mr. Senior Dev. So he was suggesting that, let's say like in block, you create all your blocks when you start the application, right? But my question last time for GetText was, what if you won't even get to that screen? So you've created something but you're not going to use it. So the approach that MVVM suggests is when you go to the screen, that's when you create the view model. So like this is the navigation. This getRoot function is actually the one that navigates. So it creates that view. So for the splash screen, once you get to that screen is where you can actually create the view model. So I have service locators for the repositories. The repositories should be in service locators or dependency injection. I haven't reached there yet, but that should be the rule. So it's easy to, the repositories are like singletons. They're one should be there. Use cases, you create them every time you want to use them. View models, when the view is destroyed, the view model is destroyed. As the same it is for Android. So this is how it looks. For the splash, I have my view and I have my view model there. For the profile, I have my model, my view, and my view model. So all my states they live in the models. If I have a profile state, it's there. Loading, loaded. Profile picture state is also there. My screen, it injects those two view models into them. So my profile screen has a logout view model because of the logout button, and it has a profile view model to display the profile of the user. So on my view, that's on my view. On my view models, here's the logout view model. It has a logout use case that has one function called logout. For the profile, it has a stream that receives updates from the view model, from the repository. So any update made on the device repository will be updated by this stream subscription here. I listen to any device update, so it bubbles up. So the repository should be the one to expose that change. So you just listen to it. All right, so that's on the packet structure. So dependency injection. So dependency injection, it allows classes to define the dependencies that constructing them. So benefits are interchangeably, as I've shown you. I changed the Firebase with the backend one. Has a clear separation of APIs and implementation modules. You can develop multiple implementations for the same API and switch between them without changing the code that you gave the API. It allows for decoupling. The separation means that modules using the abstraction don't depend on any specific technology. Like you've seen, easily changing from Firebase Cloud to the Spring backend. Testability. Separating APIs from the implementations can greatly facilitate testing. You can write test cases against the API contracts. So when you do like abstract classes, they're like contracts. It's what you agree that you will use. So it's easy to test against them. I didn't have time to test, but I did one test. Okay. So I was testing my local file storage service. So I created a mock that uses a map as the database. So what it does is like this cache. So this is the contract. This local file storage service is a contract. It should have this function called cache local file that takes in a binary and returns this result. Get cache file data takes a SHA-1. SHA-1 is like when you encrypt, you can calculate the hash for objects and get like a specific hash number. So if anything changes in that object, the hash will change. So every time I get like a file and it's computed, every time I cache a file from this function, it returns that SHA-1. So if I put a file in a box, I expect to get that file when I go to the box. That's just basically the test. Yeah. So you can see they run and they work. Yeah. So these are just the tests. Let's see. That's one dependency injection. Dependency inversion is when you keep your abstractions from concrete implementations. So abstraction is a contract. If you've used interfaces before, they define like the rules that you agree on. So you define your contract, and the contract is what you use. It's a sure way of getting what you want. The implementation, you leave it up to the maintainers of the code. So abstraction, a contract that defines how components or modules in an application interact with each other. Abstraction modules define the API of your system and contain interfaces and models. So models are what, like here, this is your contract. Models are what you get back. The results, the cache file results, you get back the file in the SHA-1. So that those are the methods and the models and the methods. So concrete implementation, and now they depend on the abstraction. So like for example, this mock, this mock storage, it depends on this abstraction, it implements it, and it's forced to override these methods. So when you override them, you expect some certain results from them. That's when your tests come into place. Right. So when do you need to do this? If you have diverse capabilities, like multiple implementations of the system, if you have multiple applications, for example, you have an application for your admin, an application for your user, you might want to have some common agreement that this is what we need to implement. So it's easy, you cannot break this contract. If you have independent teams and you all need to do different functions, so you have a contract that you agree on, these abstract classes, for example, you just need to implement this, and it should be easy to understand. If you're dealing with large code bases, it'll be easy to break it down to abstract classes, so that you don't need to worry about the implementation in certain sectors. Okay, this should be the last part, modularization. So modularization is the practice of organizing code bases into loosely coupled, self-contained, independent parts that serve a clear purpose. By dividing a problem into smaller and easier to solve problems, you reduce the complexity of designing and maintaining a large system. So in my project, I have a couple of modules that I use all the time. So I have a network service. This is a module in itself. As I said, it lives in Git. I just imported it here, just so it's easy to use. So you can import modules by path or by Git. So I have a common exception module. It's pretty simple. It's called an app failure. Implements an exception, has a message, the type of the failure that are defined here, and a stack trace, which can really be anything. So this is what I import at the base of the application, which is my data layer. So every exception that I get will be an app failure, which is easy to clearly read. You have another module called a logger, for example. You define a logging service, which is abstract, and this is what I use throughout my application. So variable many methods of logging and their style. So these are examples of modules you can have. I have a toast module. Every time I have a new application and I want to toast, I don't really think about it. I just import it and I just begin using it. So once you're in a team, you can imagine we're in a team and we're trying to do all these functions together. You know, one person may decide to use a different toast function, another may decide to use like elegant toast. So you just import this one module that maybe one developer has worked on, and it's so easy to just hit the road running and just keep going. Everyone maintains their own module, and you don't really have to worry about breaking the code. So what are the benefits of modularization? One, flexibility. It enables opportunities for code sharing and building multiple apps from the same foundation. Strict visibility control. It's easy to hide public and private methods. Encapsulation. Each part of the code should have the smallest possible amount of knowledge about other parts. Only concerned with whatever is about that module. Ownership. A module can have a dedicated owner who is responsible for maintaining the code. So, like if you're having like a big system, for example, and you need someone to work on it. It's easy to say that okay, you will just manage this module. That's all you need to worry about. Don't worry about the rest of the application. This is all you need to do. So any change that comes, you're the guru of the module. You're the one who knows maybe what you did, what the bugs are. So you will just handle it on your side. Testability, writing testable code where each component can be easily tested in isolation. So there are common patterns for modularization: high cohesion and low coupling. Low coupling is the degree to which modules depend on each other. So modules are independent. they're independent components. They can live by themselves and they do one function. So modules should be as independent as possible from one another. That changes to one module to have zero minimal impact on other modules. They shouldn't have knowledge on the inner workings of other modules. They just do whatever they're supposed to do. So that's on coupling. So it's a good practice to have loop coupling in modern applications so that it's easy to just swap out the modules. Cohesion, how the elements of a single module are functionally related. Modules should comprise a collection of code that acts as a system. Should have clearly defined responsibilities, stay within boundaries of a certain domain knowledge. So cohesion is how they're related. Like, for example, the layers. They should be closely related, but at the same time they should be easy to swap out. Right. So these are examples of common models you can have. When you go to PubDev and you look for like a paging paging package, that's like a component, that's a UI component layer. Themes, for example, this chameleon theme. Networks, if you're looking for DO or HTTP, it's easy to just get this module and just they work in your application. Utility models, things like encoding, hashing, crypto package, those are all modules. So now these are my recommendations for you. So you need to have, keep the UI as lean as possible. For the UI, it's just paint it as it is, and the view model will change that state. Have a single source of truth, that's the owner of the data. And only that single source of truth can modify or mutate it. So this is to avoid side effects and bugs. So have at least two layers, the UI and the data layer. Don't store data in the logic and logic in the app components. So as I said, the UI will just paint whatever is currently there. Consider how to make each part of your app testable in isolation. So types are responsible for their own concurrency policy. This means this is for multi-threading. So if you're doing work as a user, anything related to user, it should be responsible for threading and all that. If anything that you need, it's responsible for it. So persist as much relevant and fresh data as possible. This means keep updating. Since the repository is a single source of truth in your caching, and you have a local database and you still have online, try to keep updating the local data as much as possible. If you need to update the UI, have like a stream that keeps on updating the UI. So also use a domain layer. I would recommend personally. I think it makes things much easier, especially coming from a backend. Please use immutable data models. So use freezed. When you're changing something, it shouldn't be, only the repository should be responsible for changing that data. So everything else should be immutable. And lastly, use dependency injection. So for dependency injection, your repositories, and anything that leaves the application, I should leave the whole application with dependency injection. So that's been my talk. So you can scan this to see my website and reach out to me. So are there any questions? It's quite a heavy topic. Trust me, it took more time researching than actually writing the topics. But like me, what I can say is, since I started using MVVM, like I've noticed a significant improvement in my applications. There's the application we did. It was really UI heavy, and I really couldn't figure out how to do it without thinking about MVVM. But it really made it so simple, and it made the rules so clear. It made the function so clear. This is what I need to do. You just do that part, and now you think about later how to integrate it. Yes. So any questions?
I have a question.
Yes, you
Couple.
have.
Depending on, okay, for what I believe, as much as phones are evolving, evolving in the form that phones, mobile phones now come with much larger storage, right? But then, doesn't MVVM make your application even heavier?
That's a good question. I think I had the same concern when I was doing it. But it's good to see how things are practically on the ground. Yes, you have this many classes, you're adding more classes to your code. But when you're thinking about performance in an application, it may add some storage, but it's not as much as you think. These classes and these components are actually very small. If you look at how big a text file is in your application, it's actually very small, and that's not actually what carries the weight of the application. So if you think about being heavy, you're measuring the performance of your application. So when I tested my application before MVVM and after, I actually noticed like a much significant performance improvements. The memory was low based on how you're creating the models. You only create them when you need them. So at one point, you may have more CPU usage based on because you're creating them, but your memory usage will be less, and you only get what you need. So it's especially good for large code bases if you need to really scale out and maintain your application. It's also okay if you're using for small code bases. You really don't have to. You won't really notice the benefits. It's easier just to put a function there in the UI if you need it. But if you're using for scalable application and you're thinking big, I think the benefits outweigh anything else.
Very nice, yeah. Okay, so how long? I think you can actually upgrade an app from MVP or whatever VP someone is using to MVVM, right?
Yeah.
So how long would this take for someone who's coming to this talk and they're really motivated and they have an app that they feel like they don't want to move from MVP to MVVM? How long will it actually take them to achieve?
Good question. So
Keeping in mind that they are capable, they just good in writing code. Writing the code is not an issue. So how long will it take to migrate my app from an MVP to an MVVM?
So assuming that you have a clear idea of what your application does, you have well-defined inputs and outputs, it really shouldn't take you a long time. The challenge will be when you have code that's written by so many developers, and if you're removing a comment, it will actually break your code. That will be the challenge, but I think the steps to migrating your code base. I think the first thing would be to have a clear definition of what your application does. Once you have that, migrating to MVVM, it's just encapsulating all the classes together, all the functions all the user functions together, all the device functions together, for example. And that shouldn't take you too much time. But you need to test your code, you need to write tests for your code to make sure they will function exactly the same way you are expecting. I think Linux at the time we did the MVVM upgrade. It took around, I think 2 days. Yeah, and so it took 2 days just to change the whole architecture. So we noticed like some significant improvements on the application, and I would highly recommend. So depending to answer your question, I think you can do it in a week.
In a week.
Have I answered your question?
That's a very specific answer. Given that I didn't tell you how
big
large
the code
the code base was, but yeah, you've actually answered my question.
Any more? So So anyone else? I might just answer this one. So this one, just a comment, good talk. Thank you for that. So should the UI layer and data layer be aware of how we answered your question? Yeah. So thank you for listening to me. I hope you've tried the application. Yeah. So you can add me. There's a part where you scan someone else's QR code and you can chat. All the chats are live. They happen instantaneously.